Right, so here we go for example 2. We have a chemist dissolve 15 grams of iron 3 oxide to prepare a 150 ml solution. What are the molar concentrations of the iron ions and the oxygen ions in the solution? So we're asking you for the concentration of two ions. In the previous example, we just asked you for one of the ions, okay? But here we're asking you for the concentration of both ions. I'm going to show you one method right now, just the same method we did before, but there's other methods that you can use. But our first step, regardless of the method we're using, what should we do? Right, write that dissociation equation. Let's do it. So we have our iron 3 oxide here. It's going to start off as a solid, and then we're going to throw it in some water, and then we're going to make our ions here. So iron plus 3 plus O2 minus. Remember, I knew it was plus 3 because I did the reverse crisscross, so I sent this up here and this up here, right? So you need to remember it's plus 3. Luckily with stoichiometry, it won't really affect your numerical answers too much, but you do have to pay attention to that. And it will actually throw your balancing off if you look at charges too. So just make sure you do your crisscross to get the proper charge. So we have 2 of these and 3 of these. So we have our balanced equation. We're not 100% done yet. Actually, this wouldn't be a very complete equation. What do I have to put next to the ions? Nice. So we're looking at ions dissolved in water. Aqueous. Perfect. So let's write down information that we have. We have our mass of this is 15.0 grams. And we have our volumes provided to us. So we have a beaker again, and we threw that into our beaker, so our entire volume is about 150.0 mils. Okay, so all the ions are dissolved within this volume. So basically, for each of these ions, we would say the volume is 150.0 milliliters, or about 0.15 liters. Because when we do molarity, we want to have moles per liter as opposed to moles per milliliter. Okay? So we have our volumes, and we want to find the concentration of each of these. So if we have the volumes, what's the only thing we're missing for each of these? Right, we're just missing the moles for each one of those. So how can we find the moles for that? That's right. So we have masses already for one of these. Let's convert it to moles and then use the mole ratios to find the moles of all those. Let's just go ahead and do that. So let's do our molar mass here. Let's see. So we have 48 plus 55.85 times 2. And if I make a mistake, let me know just in case. I don't want to carry the mistake out too long. So 159.7 grams per mole. And our mole is going to be mass over molar mass, which is 15.0 grams over 159.7 grams per mole. Cross those out and we get moles are 0.093926111. Perfect. Thank you. Moles. So that's the number of moles of iron 3 oxide that we have. So now we have to find the moles of everything else using our mole ratios. So we're basically doing that for both items here. Okay, so let's call this one over here. That's step 1. I guess we'll call this step 2 technically. And then step 3, we're going to go ahead and find the moles of each of these things here. And we can do that using our mole ratios. So we'll start with the moles of iron 3 plus here. So that's a 1-to-2 ratio. It's a 1 to 2 ratio. Now I'm going to shorten the way I write the units just to save some space here, but basically what I'm doing is I'm taking my moles of the iron 3 oxide. I'm doing 0.093 0.0939 times, and you would do the units much the same way we normally do, but again, to save space, I'm just showing you this here like this. So times 2 over 1, and that should give you your number of moles of the iron 3 plus. So your 0.093926111 times 2 would give you about 0.1878522 moles of the iron 3 plus. This is still at step 3, but I'm doing the same thing for oxygen now because we want to find the concentration of both, right? Does that make sense? So I want to find the concentration of both, so I need the moles of both. I'm just kind of doing it separately, okay? I'm doing it one step at a time here. So now, what's the ratio between the iron 3 oxide and the oxygen, or the oxide ion? Right, I see a 1 to 3 there. That's right. So we're going to have a 1 to Fe2O3 to 3O2 minus ratio. So I'm going to do the same thing. Take my moles of the Fe2O3, so 0.0939, and then whatever else is there, times 3 divided by 1, and I will get, so times 3, about 0.281778333 moles. So what I've done is I found the number of moles of each of those. What's my last step now? What was the question really asking for? Right, exactly. So the step 4 is finding your concentration of each. So I'm going to write this out just in case I forgot to tell you this. Rather than write concentration of every single time, I can put in square brackets. I think it was in one of my videos. I can put in square brackets Fe plus 3. That means concentration of Fe plus 3, okay, is going to be equal to the N over V, which is going to be equal to the 0.187, so on and so forth, moles, divided by our volume, which is 0.15 liters. And I'll get, so 0.1878522 divided by 0.15, 1.2523 keeps going moles per liter, which is approximately, we have 3 sig figs is the smallest. So it's about 1.25 moles per liter. And then you can do the same process, but for oxygen. So you could say concentration of the oxide is equal to is N over V, which is going to be equal to, so our N was 0.281778333. So 0.28177 keeps going moles over the same volume, 0.15 liters, which is equal to 1.8785 keeps going. Whoops, I wrote 18 there by accident when I meant to say 1.878 moles per liter, which is approximately to 3 sig figs, 1.88 moles per liter. 1.88 moles per liter. So here I have my concentration of O2, which is 1.8 moles per liter, and my concentration of Fe plus 3. So to summarize, what I did is I wrote my dissociation equation, and the question was asking me to find the concentration of each ion there. To do that, I needed the volume, and the volume was given to me as 0.15 liters, or 150 mils, but I divided by 1,000 to find it in liters because that's what molarity is given it. So I want to find the molar concentration. I need the moles of each. So to find the moles of each, what I had to do is I converted the mass of the iron 3 oxide into moles. And then I used the moles here with the mole ratio to find the moles of each, like that. And then I took the moles of each ion. So for example, I took the iron ion here. I divided it by volume to get its concentration to the correct number of sig figs after, which was 3 sig figs. And then I did the same thing for oxygen. I just took its moles, divided it by the volume, and then I got my correct concentration for oxygen to the correct number of sig figs. That is a long process. There's a shorter process that'll work too, and I'll show you that in the next example. Are there any questions about this one right now? Anything that I need to clarify? Let me know, and I'll clarify that. In the question where it says 150 mils of solution, so yeah, there shouldn't be a plural there. What I meant to say there was 150 mils total solution. So we basically just dissolved it, so our solution reached 150 mils. And in that 150 mils, we have our iron 2 plus, we have our O2 minus collectively in there together. So it's a total of 150 mils. There are some questions where we do have to add volumes up, but they'll be more clear. It'll be something along the lines of, we've mixed 10 mils of this with 20 mils of that, and then you add your volumes up. Here we just basically said we get a solution of 150 mils. Awesome question. Any other questions? All right, so I'm going to stop that recording there because that's going to be another video. And also, we don't want everyone to see that we're shopping on EB Games.